Okay, thank you for coming to the first session of the day. I'm excited to announce our next speaker, Matt Knight. Him and his other half, Diana from Adventurous Way, are traveling around in an RV, and their mission is to visit all of the national parks. But he does a lot. They have a YouTube channel, and today he's going to teach you about the basics of your electrical systems in your RV and help you get the most out of them and maximize your capabilities. So please give it up for Matt Knight.
Hello, everyone. How are you all doing today? Happy Friday. Happy Friday. What an amazing week this has been, right? This has been pretty crazy. It's also been sunny, which I don't know about you guys, but for us, we run on solar. We're pretty pleased it's been sunny all week. That was not the case last year. Who was here last year, just by way of show of hands? Okay, good mix. Good mix. Cool, cool. Well, let's jump straight in. Today, what I want to do is the RV electrical presentation for people who don't do RV electrical presentations. This is basic. This is just going to give you a ground knowledge in what your RV has, and maybe some of the things that you might run into as limits, and then what you can do about those. So how you can start to extend your capability to have more fun. Because let's be honest, that's what we love doing. Before I jump into the electrical stuff, let me share a little bit about me. So as Mel said, I travel with my beautiful girlfriend, Diana, here, and we are traveling around the US in our RV. Now, I'm originally from England. You may have guessed from my accent. I am not from Texas, despite the plates on our truck. I give some people some confusion when they greet me and say, "Where in Texas are you from?" And I say, "Near Houston," and they're like, "You really don't sound like that." And Diana is also from Latvia as well. We used to live in the Bay Area in California, and we left our home there about 18 months ago and hit the road in our RV, which is an outdoors RV travel trailer. So you may not have heard of Outdoors RV, but you may have heard of Arctic Fox and Northwood, who are kind of sister brands of Outdoors RV. And our little 25-foot trailer is towed by our F-150, which I have not been off-roading in this year because I don't want to pop 3 tires again at the bash. So I'm playing it a little safe this year. We have on our RV an electrical upgraded system that we did ourselves. And many of you, I'm sure here, have systems that you've upgraded, or perhaps you're interested in upgrading your system. One of the things I want to kind of share, and you'll see as a theme throughout the presentation today, is there is no perfect system for everybody. You need to decide what's important to you, what you value, and some of the things then that you can do to achieve those goals. I'm going to talk you through some of those. We have about 600 watts of solar on the roof. We have a 200 watt ground deploy portable panel, and that is coupled to 300 amp hours of Battle-Born lithium batteries, a 3000 volt amp multi-plus inverter from Victron, and then we have this mystical DC to DC charger, which I will talk more about later. And lastly, as Mel said in the intro, we are on a quest not just to visit the national parks, but all of the national park units, all 419 of them across the US. No, we will not be taking our RV to Guam and American Samoa. We will use a plane to get there, but we are having a lot of fun traveling around at the moment. So, you've heard a little bit about me. I want to hear a little bit about you guys, though. So let's do a bit of a calibration effort here. Can I ask everybody to stand up, please? So, we're going to play a little game, and I want you to stay standing. If you know how to, plug into shore power. Let's just double check we're all on the same page here. Did anyone sit down? There's a couple back there looking suspicious. Okay, good. Stay standing if you know how to check your battery voltage. Okay, 1 or 2. That's pretty good, though. Pretty good. Stay standing if you know how to install solar panels. Okay. Okay. Finally, stay standing if you know how to wire up an inverter. No, you can't stand back up. Okay, so all of you sitting down, have a look around the room at the people standing up. When you have really difficult questions later during the Q&A, these are the people that we're going to be picking on to answer those questions. Okay, so joke aside, everyone can sit down now. I just want to do that as an example, though, just to show the diversity in the audience here. There are people who are really new to this lifestyle, and I know certainly when we hit the road, this was foreign to us. We didn't know a lot of this stuff. Yet you've got some people in the room who are experts. They are professional, and they do these things. They are very, very knowledgeable, but they're our peers. They're part of this community, and I know personally there are so many people who are happy to help out if you have questions. So please bear that in mind as we go through this. Here's the things we're going to cover today. I just want to give everyone a grounding in the basics of RV electrical systems, just so we're all on the same page about some of the terminology, some of the systems that we have in our RVs. It doesn't matter if you have a motorhome or a travel trailer or a truck camper. It doesn't matter. We're just going to keep it real high level, real simple. Then I'm going to go through the three big areas of electricity: how you consume electricity, how you generate electricity, and how you store electricity. They're really the big three areas. And then I imagine by that point we'll have a lot of questions on, like, I may be able to do some of this, but I may not be able to do other parts of it. Do I need to hire a pro? Can I do it myself? What's the advice there? And then there will be not a final exam. I tried. They said no. They've kept the doors open. They wouldn't lock you in. We are going to be doing a Q&A session at the end to try and pick up all those things that people have. So let's jump straight into it with an introduction to RV electrical systems. Now, this diagram is really just showing the big components that you've got in your RV. If you are in a towable RV, then obviously you don't have the engine mounted within the RV, but it's still there on your tow vehicle. The things I want you to look at are these. The green arrows that you can maybe just about see, they're a little bit bright on here, they represent your 12-volt DC system. So typically, most RVs will run a 12-volt system for all of your low-voltage devices. These are things like your lights. These are things like your jacks and your slide motors. Those water pump, those sorts of things will all run on 12 volts typically. Now again, I'm sure there are people in this room who don't use 12 volts and have other things going on, but typically that's the case for most RVs. There's then this other system that sits alongside that, which is the blue arrows. And this is what you typically have as your AC voltages, your 110 volt systems. And that's your residential systems. Depending on what you've got in your RV, that stuff may only work when you are hooked up to shore power or a generator. But as we'll see as we go through, one of the things you can do is install an inverter. So there are two terms I want to introduce to the room now. These are inverter and converter. An inverter takes the power stored in your batteries, the 12-volt power, and turns it into 120 volts of AC power that we can use to power big appliances, our air conditioning units, our microwaves, anything that plugs into a wall outlet typically. Now, depending on how big your batteries are and how powerful your inverter is, you may or may not be able to power some of those really big devices, but the concept is the same. So that's an inverter. It inverts from DC, 12 volts DC typically, to 120 volts AC. Going the other way round, we use a converter. So when you plug into shore power, you get 120 volts coming into your rig, and the converter turns that into 12 volts DC to run all of the 12-volt appliances in there and charge your batteries. So these are kind of the two components that sit between the high voltage 120 volts AC and the low voltage 12-volt DC. For today, we're really going to be focusing just on the green section, just the 12 volts. But bear in mind, some areas will be 120 volts, and just think about that as we go through. The last two things I want to point out on here are the solar panels you can see on the top. We do not have a generator. We'll use our rig and our setup a few times as examples during this presentation. We rely entirely on solar power for getting our power when we are camping. People in this room, I know, have some phenomenal setups. I'm sure you guys have seen some of them with astronomical amounts of solar. I'm looking right at Mr. Quimby in the middle there. There are some beautiful, beautiful systems out there. There's also some very small systems that may be just enough. That's all you need. It's very, very personal and will help you work out what you need. The last thing on here is the batteries. I'm going to call those today the electrical tank. So all those people who know about electrics, just cover your ears. I know that's horrible, but go with me. Think of it like any other tank on your RV. your fresh tank. You need to fill it up, and then you'll consume from it. The bigger the fresh tank, the longer you can last between fill-ups. But eventually it will run out. And your batteries, your electrical tank, are much the same. You're going to put electricity in. So you think like shore power is like the freshwater version of the electrical version of fresh water. You're filling it up with electricity, and then you're going to drain that out. You're going to consume all of that electricity into your appliances to power the things in your RV. Now, one of the big things in anything about this is safety. I really want to stress this kind of point. You've got to be very, very careful with this stuff, but please don't be scared of it. Electricity is something to be respected. It's really something that you have to think about, but certainly when we're dealing with 12-volt DC, these are low-voltage systems. You can walk up to a 12-volt battery and you can grab both terminals in your hands at the same time. You will not get an electric shock from that, but there are definitely ways you can cause a lot of damage with 12 volts DC. So what I'd say to you is be safe, do your research on what you're doing, and be careful, but don't be scared. When you get onto the AC side, the risk elevates a little bit. The risk of electrocution is there. Elocution as well. The risk of electrocution is a lot higher, obviously, with higher voltages, so do be very careful there. If at any point you do not feel 100% confident in what you're doing, ask. There are so many people in here who are happy to help. There are Facebook groups. The Xscapers community itself is always happy to help if you have questions. So please, please do that. So let's jump straight into the first topic. I want to talk about consuming electricity. Now, there are a lot of different ways you can do this. I've seen a lot of different people talk about how to identify different devices. I want to try and boil this right down to the basics. I want to give you the tools that you need to look at something and know, is that using a lot of power or not? Is that a low, medium, or high power device? We'll start with low power devices. These are typically small consumer devices. They nearly always have a battery and often charge from USB nowadays. That's a really common thing. Another one is the little barrel jacks, the round little plugs. They're often low power devices as well. These are things that consume up to about, say, 30 watts. Just to give a couple of examples here, take a phone. A phone charging from USB will draw no more than 12 watts. That's the maximum that a standard USB connection can draw. Something like an iPad that uses a slightly higher one, maybe up to about 30 watts. Cameras, lights, a few watts. The one that you may or may not expect to see on here is the propane version of your fridge. So if you have a fridge that can run on propane, it does still need electricity. You have a little pump system in there. There's a control board. It has some LEDs usually. It does draw some power, but really, really not very much. Somewhere around 3 watts is what you can expect from that. So it's a very low power device. So if you do have a propane fridge, I wouldn't worry about turning that off to save power. It's really not going to be very much. It's about the same as one small LED light. So, as we ramp up slightly, we get to the medium power devices. These often run on 120 volts AC, and quite often they might have a power brick. You know that black block that sits on the cord? That's a good sign this is probably getting into the medium power area. Sometimes they will have a battery. So think like a laptop, for example. It plugs into the wall outlet and you've got a power brick on there, but it does still have a battery inside. And typically I like to think of medium power devices as things using up to about 400 watts. So this is a fairly substantial load on a small electrical system in an RV. You will really start to feel this add up over time. So what are some of the examples here? Things like your laptop. Things like maybe a TV. Depending on the size, a bigger TV needs more power than a smaller TV. Things like your furnace. Who here has had their furnace kill their batteries overnight because their batteries couldn't handle it? Yeah? So that's because your furnace is one of these medium power devices. It could be, ours is about 90 watts. Some of them can be a couple of 100 watts. So just have a think about that. I've put the fridge on here again. So on the last slide, we saw a fridge running on propane uses a few watts just to power the control board. Here we have the fridge running on AC. Now there's 2 different modes to that. If you have a conventional RV fridge, then when that runs on AC, that will use really quite a lot of power. It's a very inefficient system, and it'll use somewhere between 300 and 400 watts typically. A residential fridge is a much more efficient fridge running on AC. And so a residential fridge is typically somewhere in the 1 to 150 watts. So better than the RV fridge, but you don't have the option to run it on propane. We have a propane fridge, and in summer, when we're electrically abundant with all of the solar, we can run ours on AC mode. The last slide I'm going to look at here on consuming data is the high power devices. These are the ones where if you want to start running these, you've got to have either a pretty decent generator or an inverter or shore power, and you're going to drain your batteries pretty quickly unless you've got a big solar array up top. These are always things that are going to run on AC power. You will not find DC things here with almost no exceptions, just because the power draw is so high that DC is just not the right way of doing that. A really good way to identify these things is they normally have heating elements or big motors in them. Little motors like hand blenders, they're fine, but big motors here. And these are things that can consume up to 2,000 watts, so a big step change from what we had before. And some of the things you're going to be thinking of here are a lot of kitchen appliances. They heat things up. The Instant Pot has a 1,000-watt heating element in the 6-quart model. A microwave can be 1,500 watts. An induction stove can be up to 1,800 watts. Your AC unit on the roof can be anywhere from 1,500 watts upwards for a standard one. And your electric water heater. So all of those things with big heating elements, you want to make sure that you really know when you're using those, because you will drain your batteries fast, assuming you even have the inverter to do it in the first place. Otherwise, wait until you have shore power or your generator on these. I'm going to talk about the dreaded electrical audit. Who's heard the term electrical audit before? Just show of hands. Keep your hand up if you've done it. Yeah, about half. It's actually really worth doing, joking aside. But it's tedious. No one likes to do it. So I want to show you a few little tricks you can use if you kind of want to do it, but you don't really want to do it. So first one, go to an RV park where they have metered electricity. Even if you're not paying a metered rate, try and camp like you would when you're dry camping. So don't run the AC all day. Don't use the microwave all the time. Don't use your electric water heater. Camp there for a few days and then just see on the meter outside how much power you've used. It won't be perfect. I'm sure you'll have just gone, just this once I'll use the microwave. But it's a good starting point just to kind of put you in the ballpark of how much power you're using. Next step up, if you want to try something a little bit more advanced, try one of these devices. They're about $35 and they're called a kilowatt. And you can get these from Walmart, from Amazon. And all you do is you plug your device, you plug this into the wall outlet and you plug your device into it. And it'll tell you how much power that device is drawing. Really good way just to see on a single device. If you are very careful, you can plug your whole RV into these. But think of it like mooch docking. You can't draw more than 15 amps because that's all this thing is rated for. But if you just want to see a little bit more accurately how much power your rig is drawing, say when it's just idle, so you don't think there's really anything running, it's a good way just to see what's going on inside. The standard way that a lot of people start is by looking on those power bricks, and you can read the label. And one of the things, I kind of promised no math and no complex stuff today, but one little one here, if you want to calculate the number of watts that something uses, you take the number of amps and multiply it by the number of volts. So on here, on this label, it's a little hard to see, but up here, I think it says 12 volts and 5 amps. So 12 times 5 is 60 watts. That doesn't mean the device will use 60 watts. It does mean it cannot use more than 60 watts. So for example, a laptop charger will use the most power when you're charging your laptop, but once it's charged, the power will drop back down again. So if you do start to use this method, just remember that's always a maximum. It'll never be more than that. But that's not a bad place to start from, right? It's the conservative approach. The gold star of this show is one of these. So this is a battery monitor with a shunt. And a shunt is basically like a flow meter for electricity. Does anyone use a flow meter on their water, their freshwater hoses or anything? A few people. Okay, good. I thought I was the only weird one here. So all it does is it just measures the amount of electricity going into and out of your batteries. It's a really good way to see how much power you're using. And what you can do is you can have everything turned off. You can start from that number because there'll be a little bit of background draw for your propane alarm and things like this. Turn something on, and it'll tell you exactly how much power it's using. The big advantage this has is it can see DC loads. The other ones, the kilowatt, for example, you can only use for AC devices. So you can't plug in a like a normal USB socket, without going through one of those wall warts. You can't do those sorts of things, or a 12-volt plug-in thing. It can't do those. The shunt can. So that's your winning device. I want to round off this section with some tips. How to conserve power, because this is all about things that use up the power. What can we do to conserve the power? First one is just avoid using it. If you know which devices in your rig are using the most power, the coffee machine, the microwave, maybe think about, is there a different way to do that? Can we do a stovetop kettle rather than heating up water in the microwave? These can be really good ways of conserving power, especially when we're off-grid. Shore power obviously doesn't matter. One of the things that we do a lot of is we use propane when we're off-grid. So plug me into shore power, my electricity usage is through the roof. I've got the electric water heater going, I've got the microwave going, the electric kettle's on. I need tea, I'm British, it's like my blood. We go off-grid and we switch all of that to propane. The fridge moves on to propane, we heat our water with propane. We don't leave that on all day because it'll just eat all the propane. Just look at some of the options you've got in your rig, and especially if you're looking at changing things in your rig, what can I do to use propane rather than electricity, if that helps? Reduce the overnight temperature. I know this may not be a popular one, but just a thicker duvet, thicker blanket on the bed can save a lot of power if the furnace doesn't need to kick on as much. Remember, that furnace is going to be using somewhere 100, 150 watts of power. If that's running a couple of hours during the night, that's really going to eat up a lot of power on a small system. So just think about whether there's things there that you can do as well. Who here has an inverter in their RV? Okay, basically everyone. Fantastic. Okay, so inverters are great because they let you use all these other things, but the background draw on an inverter can be really, really high. So to give an example, our rig, we have 3 Battle-Born batteries, and we have 3,000, Victron Multiplus 3000 inverter, so a fairly big inverter, enough to invert our whole coach. The background draw on that inverter is about 35 watts. What I mean by this is if I turn everything off, I disconnect the breakers, there is no load on the system at all, that inverter is just burning 35 watts all the time. So one of the things that we do is we turn it off all the time, and we only turn it on when we need it. We want to use the blender to make a smoothie, turn the inverter on, make the smoothie, remember to turn the inverter off. It works most of the time. Just to give some context there, if we didn't do that, if we just left our rig with just the inverter on, everything else turned off, and no solar coming in, our batteries would go from 100% to 0 in 4 days. Nothing has run. Just the inverter, 4 days, it's dead. So this is a big one. If you have the ability to turn the inverter off, it makes a big difference. And lastly, when you come out of a residential environment, you move into your RV, you start to just take all your appliances in, your laptops and everything else, and you just plug them into 110-volt outlets and run the inverter. We know that you pay a tax now for running the inverter, but also you pay a big tax to convert your DC power to AC power through the inverter, through that power brick for your laptop, back to DC, which is what the laptop needs. My best tip in the whole presentation is if you have devices that you think are in the medium power category and have one of those power bricks, go onto Amazon and search car charger for whatever. So if you've got a Dell laptop, car charger for Dell laptop. That will often let you just plug straight into a 12-volt socket in your rig. You don't need the inverter anymore, and it's a lot more efficient. They can be about 30 to 40% inefficient when you go through the inverter. So real one to think about there. Okay, let's jump on to generating electricity. 3 big ways here, and I'm going to move through this a little bit quicker because I'm pretty sure most people are fairly comfortable with all of this. We'll start with generators. Put your hand up if you do not have a generator. Yeah, most people. A lot of people have a generator, and for good reason. There's a lot of advantages to them. They're pretty simple. You can walk into Walmart and buy one. They're easy to use. They're not that expensive. You can get, certainly you get Harbor Freight or something, and you can pick one up real cheap. And they're actually really powerful. A smallish inverter can often power the AC in your rig. So there's a lot of advantages to them. Why do I hate them? They're noisy and heavy. You've got to carry fuel, particularly if you've got a diesel RV or a diesel truck. Now you've got to carry separately a load of gasoline for your generator. So that's kind of a pain. And they do need maintenance and regular use. And I know there's some people who they use their generators so regularly that the only time they really use it, certainly in summer, is because they have to, for maintenance, to run it for an hour or so each month. So they are good, but they're noisy, they're heavy, they have these other disadvantages. So we jump on to solar. Solar is free power. It's like having a nuclear reactor, fairly long way away, powering your RV. We love our solar. Why do we love it? Well, it's actually not that expensive. The prices have dropped so much in the last few years. You can often be paying well under $1 per watt for your solar, particularly if you have a large rig and you can do residential panels. It can be really, really good. It's silent. There's no noise from your solar panels. I love that. I also love when my neighbors love that as well, because it's silent for both of us then. And it's free. It's a really, really cost-effective way of powering your RV. But it's not perfect. It does take up space. We have a 25-foot-long travel trailer. I can't just slap 4,000 watts of solar on the roof. My roof would be significantly larger than my trailer at that point. It's also heavy. Really think about this if you have a travel trailer. The weight of those panels will add up really, really quickly. A 100-watt standard panel weighs about 16 pounds. So it's really easy to say, yeah, we'll throw 10 panels up there. That's 160 pounds of cargo you've lost just in the panel. Now add in the wiring and the solar charge controllers and everything else. It's probably about 200 pounds of cargo you've just used up there. So if you're already in certainly the ultralight trailers, just bear that in mind and have a think about it. They suck on cloudy days, don't they? Like, I remember the Bash last year, we killed our batteries. We took them to full zero. We ran out. At that time, we had no rooftop solar. We had 3 panels just propped up against some camping chairs in front of the rig, and we ran out of power because we had several cloudy days in a row. And there's less yield in winter. We just went through our first winter, or I guess are in our first winter, with solar on the roof. And it's been fascinating to see, and really depressing to see, how much less power we are getting in winter. I want to show some numbers on this, because I think we've heard this a lot. People tell us this. We have a monitoring system in our RV where we can really, really accurately see exactly how much power is coming in, how much power we're using. So I want to share some numbers with you here. We started off the year on the 1st of February, we installed 400 watts of solar panels on the roof of our RV. Thank you, Dan Brown, for your help if you're around. We stayed like that until about mid-May, and we upgraded to 600 watts of panels on the roof after someone stole our portable panel that had been helping us out. We decided, good luck stealing the one that's bolted onto the roof. So that's what the red lines here show. You can see we had 400 watts at the start of the year, and we jumped up to 600 watts there. The bars show how much power we actually brought in at max each week. What's the highest number we ever saw coming in from the panel? And you can see in summer, we were getting pretty close to maximum most weeks. The green bars, just in case you're wondering, they reflect an effect called the cloud lens effect. Who's heard of that one? Just show of hands. Yeah? This is a really unknown effect by a lot of people. On a slightly cloudy day, as the sun hits the edge of the cloud as it's going past, you actually get more output from your panels. So you'll see these little blips just occasionally as the cloud goes past, where it dips as the cloud is going past, and then goes up higher than your panel's rated to as it passes, and then back down when it's sunny again. And that's what the green bars on here show. They show the effects of the cloud lens effect. And that's why you can see in summer a couple of times we got more than 600 watts of solar from our 600 watts of solar panels. In winter, though, it's really dropped off. And someone did a survey on the Xscapers group this week, which I think was fantastic, where most people seem to be getting somewhere around 40% of the yield of the panel. In other words, a 100-watt panel is going to give you a max of 40 watts at midday on a sunny day. This is assuming the panel is flat. If you start to tilt your panels, obviously that changes, but the proportion will be roughly the same for a flat panel, full in summer and about 40% in winter. But winter has another impact as well. It's not just that the sun is lower in the sky, so you get a shallower angle of attack. You also have shorter days, which means that the sun is visible for less time. That's just less hours of solar power coming in. And it's like a double whammy, because winter is when we want the most power. We want lights on more. We want the heating on more. So we're trying to use more power. We have less hours of daylight, and when the sun is up, we get less power per hour. This graph shows the total amount of power, or the maximum amount of power that we got each week from our panels. So you can see in summer, we peaked here at nearly 4,000 watt hours of power from our 600 watts of solar panels, whereas in winter, we're now about 1.2 to 1.5 kilowatt hours. In other words, for every 100 watt panel that you have on your roof of your RV, this is, again, flat panel, you will see about 500 watt hours in summer per day, but only about 40% of that, about 200 watt hours per day in winter. Massive reduction. This is why people tilt their panels. If you have that option and you want that winter capability, great advice here is to tilt. I'll just move quickly through the alternator charging section. The pros of the alternator charging, so this is where your engine is powering your batteries. The great thing is it charges while you drive. You don't have to do anything. It can also be actually really powerful. You can pull over 100 amps if you want to from your alternator in certain situations. And there's nothing extra to carry. There's no solar panels to deploy, no generator to pull out, no gas cans to fill up. However, there's a few things to watch out for here. The first is, I said it can be really high power. It can be too high power. It can really stress your alternator. So be careful. Make sure that you know what you're doing. If you just have a load of lithium batteries in your RV, in your trailer, and you hook those up to the alternator, you can really start to cause problems there because they will overtax the alternator. So just bear that in mind. There may be some cost to buy and install some components to make this work. So there are components that can do that, and you can modify your vehicle with those. One of these is the Battery Isolation Manager, I think it's called, the BIM. And this is a device that basically stops your alternator from being overstressed by everything. We went a different route. We got one of these. This is a DC to DC charger. This is a proper battery charger that rather than plugging into like a wall outlet, you essentially plug into your truck. And that's what we do. Every time we hook up our trailer, we plug in the 7-pin, and then we plug in this separate connector. And that charges our batteries at 40 amps whenever we're driving. If you've got a travel trailer, I'll be honest, this is my favorite component in our entire electrical system. That is the reason we do not have a generator. Those emergency days when it's been cloudy for 3 days, what do? We plug the truck in if we have to. We've now got to the point where we know how to manage our power. We've done that twice in the last 12 months. But I'm not carrying a generator around to use twice in 12 months. That is a savior. Just to put it in context, if I leave on a travel day with my batteries at 0, 7.5 hours later, my batteries are full. So I can get to an RV park or a new boondocking spot, and my batteries are completely full. It's such a nice feeling to know on travel day that you have all that power available. Generating power tips. A couple of things here. Ensure your RV's charger is actually optimized for your batteries. A lot of people will buy a new RV with 12-volt batteries, and then they'll put lithium batteries in and wonder why they're not really charging very well. It's because that cheap Woofco charger that your RV came with doesn't know what lithium is. It has no idea. So it's just not going to work very well. So make sure you just do a little bit of research and say, is everything optimized? Is everything meant to work together here? Often not a problem, but just one to watch for. What we do, and I think what a lot of people do, is size your solar for your winter needs. Obviously, if you're a part-timer, you only go out in summer, not an issue at all. But if you are trying to stay off-grid during the winter, that's going to be when it hurts the most. Your usage will be highest, your generation will be lowest. So size it for then, and consider tilting if that's an option for you. What we did, tilting isn't an option for us. Just the shape of our roof and the layout means it's just not an option. And I didn't want to put any more solar on the roof. It's just getting a bit full up there now. So we have this portable panel. 200 watts of portable on the floor is doing more than 400 watts worth on the roof. A portable panel can be really, really powerful in winter. And in summer, we'll never use it. We won't need it. We'll have the power available. But in winter, it's just that extra boost. And lastly, if you do have a towable RV, consider charging from the tow vehicle. You've got a big generator called the Alternator under the hood of your car. Consider using it. It can be a really powerful asset for you. So then the last section here today is storing electricity. I know everyone's been here and seen this a lot, so I want to move through quickly, but there will be some people for whom this is new. Put your hand up if you do not have lithium batteries. Okay, good. So you'll probably have seen a lot of these things before, but I want to just demonstrate some of the things here. The most basic type of battery that you typically get on your RV when you get it from the dealer is a flooded lead-acid battery. And there's good reason that dealers do that. They're cheap. They're cheap, cheap, cheap. And they put them on all RVs. That's basically what you get as standard on nearly every RV that you buy. There are some like the Volta system that will come on vans in particular that are different, but this is the most common. You buy them at Costco, you buy them at Walmart, super, super easy to do. But they're basically terrible. They vent a corrosive gas, so you need to do maintenance to keep things clean. You need to make sure they've got ventilation in the bay where they are, so you don't cause problems there. They require maintenance to top up the distilled water, so now that's another thing to carry and to do. You can only use 50% of them. They have all these disadvantages. Have you ever lifted one? They weigh a ton. They're so heavy. A lead-acid battery can be around 80 pounds in that little box. They're insane. And I'll give you a clue. The name kind of tells you why. Lead-acid battery. They're basically the two worst things in the world, right? Lead and acid. They're terrible. There's a slightly better version, and this was really popular a few years ago. There are still some great systems out there. I'm not bashing any of these. This may be right for you. The next one, though, is sealed lead-acid, and particularly the AGM batteries. These do have some pros. They're sealed. They don't vent. They don't off-gas. So there's basically no under normal situations. So there's basically no maintenance, no leaking, no gases, etc. And they're typically higher power than flooded lead acid. The way they work is just a slightly different mechanism, same chemistry, but slightly different structure, and they're slightly higher power than sealed lead acid. But they're not perfect batteries. They do have some disadvantages. They're a lot more expensive than flooded. They're still really heavy because they're still a lead and acid battery. And you still, for the most part, can't discharge them below 50%. There are some that change slightly, but typically that's a fairly common situation. But if you've got them and they're working for you, that's great. Don't change just because there's something else out there. It may be right for you. The last one, and the one I want to talk about today, is the lithium batteries, and specifically the battle-borne batteries. They are a sponsor of this event, so I did want to talk about them, but there's another reason I want to do that as well. Dinah and I had the privilege of doing a factory tour around Battleborn's brand new factory in Sparks, Nevada, just a few months ago. We put the video on our YouTube channel, but there was a load of other stuff that they said, please don't film this. Will Prowse has subsequently filmed it all and put it out there, so definitely check out his videos as well. We were so impressed by the build quality of these things. When you see how they're made, the attention to detail, lithium isn't equal everywhere. There are big differences between lithium batteries of different manufacturers. And unfortunately, often you can't see it because it's sealed inside the box. But really bear that in mind. We got the Battleborn batteries. We paid full price for them. We installed them ourselves. We had no idea about Xscapers when we did it. We have been 100% happy with them. And I think everyone else that I've spoken to that has them has as well. And why is that? They're so much lighter. 31 pounds for the same size of battery that will put out at least double the capacity of that 80-pound lead-acid one. You can install them in any orientation. If you haven't seen the trailer next door where they've installed them upside down and backwards, that's a pretty cool one. You can also use the 100% capacity. I sometimes hear people say you can drain them down to 20%. No, that's not true. On Battleborn batteries, you can use the full 100%. Every battery that comes out of there actually has a capacity of somewhere between 103 and 108 usable. You can use that 100. You can actually use the extra few as well. And last year, when we drained our batteries to zero, we did it as an experiment to see what would happen. Kind of convenient that it was cloudy, so we didn't really have a choice in the experiment. But we took them to absolute zero. When they finally died at 9.1 volts, we had pulled 304 amp hours out of that 300 amp hour bank. It took us 11 days on solar to charge them all the way back up again. It's not the nicest way to treat the batteries, and it does no harm whatsoever. Those batteries were as good after that as they were before. No damage whatsoever. They have the highest energy density. We talked about that, the weight and the size. They last a lot longer. If we cycle this battery every single day, which we won't because we just can't use that amount of power, but if we did, after 10 years, they would still have 80 amp hours per battery left. It's basically double a lead acid after 10 years. It's insane. They're also the safest. Has anyone here ever been concerned about the safety of lithium batteries because they've seen like electric cars explode? And yeah, Dan Brown, you're always scared. It's or like the Samsung Galaxy Note things exploding. Has anyone seen those and thought, I don't want those under my bed? Yeah. I don't either. But these batteries aren't those batteries. It's a totally different chemistry. These are much safer. They're not as compact. If you look at the battery in your phone and you look at the energy density of that, it's way higher than a Battleborn lithium battery. but the Battleborn battery is much, much safer. Their latest one, if you drop a metal wrench across the terminals of the 12-volt lead-acid battery, run. Like, that's going to end really, really badly for you. If you do that on the new Battleborn batteries, nothing will happen. The BMS inside will kick it off so quickly, it will barely even spark. It's an incredible technology. Yes?
What's BMS?
Sorry, yes, good point. BMS. So a BMS is a battery monitoring system. One of the things about the lithium batteries here, it's not just a pack of battery cells. It's actually a really clever system inside as well that manages all of that. So it looks after the battery, makes sure that you don't damage it. It's really, really hard to damage these batteries because of this protection system that they have built in. And that is just such a wonderful feature. A lot of people I've seen like the lithium batteries with the external BMS because they say, I can switch out the BMS. If that's what you want to do, then that's up to you. I wouldn't, because it means you've got this death wire going from the battery to the BMS. If something goes wrong between those two, that battery is on its own. All of the protection on the Battleborn ones is internal. You cannot damage them. It's really impressive. But there is one big downside with lithium, and that's the higher upfront costs. Yeah, they're not cheap, right? But let's talk about that. We did some numbers. We've been on the road now 18 months, and we ran the math, and I want to share some of that with you. Let's look at the total cost of ownership between just flooded lead acid and lithium. I'll spec out the same bank, but just in those two different technologies, 300 amp hours at 12 volts, which is what we have. I'm going to compare the standard 12-volt interstate battery that you can go and buy at Costco or Walmart or whatever against a Battleborn 12-volt 100 amp hour battery. There are many, many different options to these. I know, excuse me, if you are doing it yourself, you've got a lot of options out there, but I'm just comparing two simple ones. This may be a realistic upgrade path for you. The lead acid weighs 84.5 pounds. It's insane. It's super, super heavy. The lithium battery only weighs 31 pounds by comparison. The lead acid ones aren't cheap. These are pretty big batteries that we're using in this configuration. They're 150 amp hours each. They also cost $289. These are not a $40 battery at Walmart. These are fairly expensive. The Battleborns are more though. $874 with your Xscapers discount code. Get 15% off the normal price. To achieve the 300 amp hours of usable capacity, you actually need 4 of the flooded lead acid, but you only need 3 of the lithiums. And that's because although the flooded lead acid ones are 150 amp hours, you can only use half, so you've only got 75 amp hours per battery available to use, whereas the 100 amp hour lithiums, you got it all. You got 100%. So actually when you add this up, you find that the flooded lead acid batteries would be 338 pounds. Just think about that for a second. I want to go and drop 350 pounds on the tongue of my 25-foot travel trailer. It's just going to go through the floor of my F-150. That's not going to work very well for us at all. And they've got to be somewhere near the tongue because they're going to vent. I need to have ventilation around them. By comparison, the Battleborn batteries are 93 pounds and we put them under the bed. Talk about cost. Yeah, there's a big difference here. The Battleborns are not too far off, twice the price of the flooded lead acids. But, and here's where it comes in, let's talk about the lifespan of these. Lead acid batteries, if you look after them, you get about 3 years. If you don't, you'll get about 3 months. By comparison, the Battleborn batteries, 10 years later, you've still got 80% of your batteries left. It's insane. There is another thing, and I think Brandon actually touched on this in the solar one the other day. You can add more batteries for up to 2 or 3 years later, and they'll kind of pair pretty nicely with your existing system. You cannot do that with flooded lead acid. They tail off so quickly that you just can't start pairing them later. On that note, never mix batteries. Don't have like one lead acid and one lithium. You kind of got to stick to one or the other. So what this means is that the cost per year is actually lower on the Battleborns. And I said earlier, we ran the numbers on ours. Give or take, our system cost about $10,000 to install. We did all of the labor ourselves, but between the batteries, the inverter, the solar panels, the charger, the DC to DC charger, switches, breakers, fuses, wires, all that stuff, somewhere in the region of $10,000, give or take. However, we worked out that our average nightly cost in an RV park is about $25 through Passport America, which basically means if we can camp off grid, we save $25 a night. So 400 nights later, we've paid for our investment by not having to have stayed in RV parks. We prefer not to anyway, so that works really well for us. We rolled over that point and broke even just a few weeks ago, so we are now officially living free on our power. So, thank you. So I'm just going to leave you some battery tips here. Yes, sorry, question.
You're on your cons, you didn't list the temperature situation.
Temperature, yes. Okay, so you're talking about lithium batteries in cold weather.
Battle-born and the charging in colds and whatnot.
Yeah, so this comes up a lot. It's kind of, I think it's a fairly unfair criticism to level at them. Let me explain why. Your battle-born batteries, you can use that to charge. You can charge your battery all the way down to somewhere around 25 to 30 Fahrenheit, somewhere in that range, which is pretty cold. That's charging. You can discharge that battery down to about -4 Fahrenheit. That means that if you have a little bit of life in your batteries or you have a source of power, you can run a little heater to heat the battery up to 25 or so and then charge it again. So -4 is where you need to stop discharging it, and it will stop it for you. You want to store that battery, -40 Fahrenheit it can go down to. Think about it this way. This is a circa $1,000 electronic device. Let's say I went out and bought a laptop for $1,000. I wouldn't store that at -40. I wouldn't put that in my freezer overnight just for fun. I would treat that like any other sensitive electronic device, and I would say, look, it's $1,000. I'm going to be careful with it. Interestingly, the same is also true of lead acid. They also diminish in capacity, particularly as you get them colder and colder. Other devices in your system, such as your inverter and your solar charge controllers, also don't want to be super cold. So you're absolutely right, there are limits on these things. But there's limits on all of these things. It's not just the lithiums. So the question was, what do you do if it has got down below that? It's got down to 6 or 7 degrees and you want to charge your batteries. Use a little bit of the power that you've got to charge with. Let's say it's shore power or a generator or something. Use a little bit of that power to heat up the batteries. So just a standard 100-watt light bulb, for example, put that in that compartment. It will very, very quickly warm those up to get them up to, say, 30 Fahrenheit, where you can then start to charge them again. Okay? Sure. Okay, so a couple of battery tips for you. If you do live full-time in your RV, lithium might actually make sense. Yes, it's a big upfront cost, but it may make sense, and I know a lot of us here are full-timers, so do the math, see what your situation is. Do you want to be off-grid? Do you want to boondock? You may find the math works out in your favor. Use a battery monitor. You can't check the state of charge using a voltmeter on lithium batteries. Even if you have lead-acid batteries, having a battery monitor is still a much, much more reliable way to know how your batteries are doing than just a voltmeter. And lastly, if you're like us, an appropriately sized battery bank may actually save you money in the long run. It will allow you to camp in free places where you are not tied to utilities because your battery bank can't get you through. Last thing I want to do, so maybe as I've been going through, a few of these ideas have kind of, you've thought about and thought, maybe I can do some of these. Maybe these are things I'd like to add to my rig. I want to add some solar or upgrade my batteries or add a DC to DC charger. Can I do it myself? Or do I need to hire someone in to do it for me? What are the options there? So the first thing I would say, have a chat with Battleborn if you are considering their batteries. These guys are super, super knowledgeable. If you give them a call and tell them what you're thinking of doing, they will help you design your system. So if you do feel confident in doing the work yourself, don't be afraid to give them a call. And then at the end of the call, you've spoken to them, you think, I don't know, man, that's a bit more than I think I feel comfortable doing. That's okay. It's cost you nothing. You've lost nothing. Check them out. Have a chat with them here. They've got a couple of guys here today. Have a chat with those guys and see. Remember I said at the start, we made all those people stand up because there's loads of knowledgeable people here? Ask them. Ask on the Xscapers Facebook group. Ping your neighbor if you see they've got a ridiculous number of solar panels and batteries. Did you do it yourself? I'm thinking of doing something similar. Could you have a look at mine, see what you think? I know we've spoken to people who've done that. People have helped us. It's a fantastic community, and use it. So that's everything from me. I hope that was really interesting for you. Now, all the people that stood up at the start, because they're super experts, I'm going to ask for your help in fielding some questions from everyone else here, but that's the end of my presentation. Okay, Diana is going to run around with a mic. If you want to have any questions, just please raise your hand. So the question was, just if you didn't hear, hybrid inverters, what are they? Do they really do what they say they're going to do? So a hybrid inverter is an inverter that can take your AC shore power coming in or your generator coming in, and if that's not enough power to run the thing you want to run, it can augment it with extra power from your batteries. So a good example of where you might use this is, let's say that you have a 30 amp rig and you go and mooch stock at a friend's house and they offer you an extension cord and you can pull 15 amps from them. If you start running your microwave and your AC and your Instant Pot and all those things, you're going to trip their breaker real fast. The hybrid inverter, you can limit it and say, never draw more than 15 amps from the shore power. And then if you need more, pull that from the battery bank. One of the things we found this really useful for is in summer. Have you ever been to an RV park and found that the power keeps browning out because everyone's running like 17 AC units and the park can't handle it? We'll set our input current limit really low so that it'll only pull, say, 15 amps from a 30 amp connection. The AC will kick on for a while. It'll pull the batteries down a little bit, but then it'll cycle off naturally. Then the batteries will start charging back up again using that shore power. So they do work really well. Magnum has them. We've got a Victron one that works really well. And it's a great, great feature. Anyone in the room who's got one? Anything else to add on that? GoPower does too. GoPower as well, yeah. I personally, I wouldn't get one that wasn't a hybrid. I love that feature. It's really useful. Yeah, so the question is, if you already got something set up, how do you kind of make it hybrid-y? Can you do it? You can. You'd probably have to have a look at the wiring a little bit more specifically and see exactly what you've got. If your existing inverter isn't a hybrid, you probably can't just hybrid it up. But you may not have to do a load of wiring work, depending how it's set up. But sure. Any other questions? One at the back here. That was the first hand up.
I added a bunch of lithium battle-borne batteries. But one of the things you said that caught my attention was I know for a fact my installer didn't do squat to my alternator on my motorhome. That and also the converter that was already in there. Should I be concerned? Am I going to blow up on the way home?
No, in an answer. This is a great opportunity, though, to kind of think about that safety thing. I think it's a good question to raise. Your alternator probably isn't going to blow up, but you may be shortening the life of it. Depending on how it's wired and maybe something was there before that was helping to limit it, you may have had some protection in there already, but I would be wanting to double check that. My best advice would be to say when your batteries aren't full and your alternator's running, your engine's running, look on your battery monitor and see how much power is going back. If it's dumping like 100 plus amps back there, you've probably got an issue. If the number's a lot lower, you're probably okay. But I would get someone to come and take a look and just see if they can advise more specifically. Anyone else want to? So just to echo what Gary said out to the room, Progressive Industries lithium specific battery isolation manager. One of the things it'll do is it'll turn on and off on I think a 15-minute cycle. So that it doesn't overheat your alternator. So 15 minutes of charging, 15 minutes to cool off. And there are better and worse stock chargers out there. So I know just on our Outdoors RV, the Wifco charger that came with ours literally has no concept of lithium. It just doesn't know what to do with it. And you can charge for days on end, and the charge will barely get over 70%. It just won't do anything. Outdoors RV, in response to that, knowing more people are adding lithium, have actually switched to a Progressive Dynamics charger in their new trailers that has a lithium profile built in, and you can switch to if you change to lithium batteries.
Hello. Is there a solar panel manufacturer you recommend for doing a ground deploy between 300 and 400 watts?
Yes. So we on our RV, we used Renogy panels. I'll explain why, just to maybe answer your question. At the end of the day, for the most part, 100 watts of panels is 100 watts of panels. There are going to be some out there that have subtly different features, but for most people, a 100 watt panel is roughly going to be the same size, area-wise. It may be a different shape, so consider that. We chose Renogy just because it was a brand that we felt was going to stick around. So if we wanted to add more panels in the future, we felt pretty confident we'd find one similar. And you kind of want to keep the same panels in the same charge controller, so you're not mixing and matching too much. We built a Renogy-based portable panel. So I bought just two 100-watt panels, made a load of hinges out of some angle and everything else. It works great, but it weighs about 35 pounds, 40 pounds. That's a 200-watt panel. So if you're wanting to do 300 or 400 watts, you're dealing with a lot of weight at that point. Did anyone here check out the Dometic rig the last few days it's been here? Do you see the Obsidian Zamp panels? Those things, like I've never been excited about a solar panel before, if I'm honest. These things are legit. So if you're going to make a portable panel, I would go with those. Just sheerly for weight and size. They're about a ½ inch thick, something like that. 3/4 inch. They're insane. They are really, really beautiful. So just for anyone who didn't hear, they use, I think it's 2.5 mil glass, 2.5 mil glass on the Zamp Obsidian panels rather than 3 mil, which would be standard. So that's why it's a little bit, or one of the reasons it's a little bit lighter. They also said, like, why does everyone keep putting a aluminum frame around every panel? That's great on a house, but crazy on an RV. And we're like, why didn't anyone else think of that before? Because they've just removed it, and it's much lighter. Other questions? Yes.
I have a system I think that's similar to yours. I'm a towable 20-foot trailer towed by a truck. And I got a beefier alternator with the specific intention to be able to have my alternator charge my batteries. So I'm interested in the DC to DC. Where is that mounted? Question one. And question two, does it have a limiter on it so that if the alternator is generating a bunch of energy, it just stops? I picked up a 350 amp alternator, a one wire,
Wow.
to put in my 250 diesel truck.
Okay, so firstly on the mounting of it, the one we use is made by a company called Red Arc. Red Arc is an Australian overlanding company, and this thing is about that big. It's a fully resin-filled unit. It's completely waterproof. You could literally just dunk it in a bucket of water, and it would carry on running quite happily all day long. We bought that because at the time, that was pretty well the only option. Sterling also makes one. That's not waterproof. Renogy now make one. That's also not waterproof. I like the Red Arc one. We mounted it under the bed next to our batteries, so in the trailer. And then I ran a 2-gauge wire all the way to the back of the truck from the alternator and another wire correspondingly on the trailer. If I did my install again, that's one of the things I would change. It gets pretty toasty because it's full of resin. It can't dissipate the heat. If I did it again, I would mount it on the frame at the front of the RV. It's totally waterproof. My RV is in way more problems if that thing goes underwater than just that thing being underwater. So it is completely safe out there, and it would be super happy mounted to a piece of like steel frame. Exactly. I just mount it on the tongue, somewhere near the propane tanks up there. If I had one of the Sterlings or the Renogies that are not waterproof, find a space. Again, I liked it on the trailer because it means you have a clean 12 volts coming out the back of the truck, which we use to power our compressor and other things as well. A couple of just notes on that though. So it doesn't have a temperature sensor built in, but because it is current limited, it's a 40 amp charger. I have a 210 amp alternator on the truck, and I was like, 40 amps, that's nothing. That's one light bar. Like it doesn't really matter. If you have a smaller alternator, just consider that. They do a 25 amp version and a 50 amp version. So you've got a couple of options there. What I also love, if like you're just like, my alternator just doesn't care, I've got oodles of power, you can parallel up to 4 of these together. So you could have 160 amps of charging power from your alternator when you're driving along. Just to put that in context, have you seen the battery bank in Courtney's amazing Montana? Her new truck is going to have dual alternators that would be able to power 4 of these. With that system, 6 hours of driving would take all 10 of her Battleborns from 0 to full. It's insane.
Let's say that you have a pair of panels on top of your truck, and you also have a trailer that you're towing, and you are wanting to have batteries in both the truck and the trailer. If you had 2 solar charge controllers, would they compete?
Okay, so that's a fairly specific question. So I'd probably want to see exactly how you got it set up. Can I answer the more general one of do 2 different solar chargers compete with one another more generally? The answer is pretty much no. If you have 2, say, Victron solar charge controllers, they'll actually cooperate. They will create their own little network between themselves if you wire them right, and they will actually work really nicely between each other. More generally, though, no, they won't, because they essentially detect the voltage that the batteries are currently at and charge accordingly. What we've observed on ours, so the Red Arc DC to DC charger that we have, has an extra little bonus feature. It has a solar input side. So you can plug in an unregulated panel, and it'll MPPT charge from that. So we use that charger for our portable panel. So we really love this little device. So essentially, right now, our trailer has 2 competing solar charge controllers. It has the Red Arc one and a Victron one. When we're driving, it has the red arc from the truck and the Victron from the roof. They do not compete until about 99.5% battery state of charge, and then typically one of them will drop off as the other goes into absorb. I'm 99.5%. They can compete all they like at that point. I really don't mind. But good question, though. Thank you. Let's do the last question here, because we're a little bit over time. We will be sticking around there afterwards, and I'm going to ask all the experts who stood up earlier, please, some of you guys stick around as well and help answer any questions.
So I'm sorry this is the last question because it's about inverters. I spoke to the Battleborn rep yesterday to confirm that my inverter converter is probably not good enough for lithium. And I spoke about the same inverter converter you have, the Victron Multi Plus, and he said it wasn't a good idea for me because I have a 50 amp rig, and he said something about one leg, so it really only provides 30 amps. Can you?
Yeah, so here's a fun little bit of RV industry math. How many amps do you get out of a 30 amp hookup? 3,600. How many amps? 30, right? How many amps do you get out of a 50 amp hookup? 100. In a 50 amp hookup, if you've ever compared the plugs, a 30 amp plug has 3 pins, a 50 amp plug has 4 pins. And that's because as you look at it, 2 of those pins have 50 amps on each. So you get 50 plus 50, you get 100 amps of power. They're called legs. Each one of those is a leg. A 30 amp rig only has the one 30 amp leg. A 50 amp rig has 2 50 amp legs. So probably the concern on yours was the Victron 3000 can only put 2,400 watts of power onto the AC side continuous. In a 50 amp rig, that is substantially less than one leg would have. So you're going to start to potentially, depending on what you try and run, you could run into difficulties. Some people say oh, it's fine, just when I'm boondocking, I know I won't use stuff, and that's okay. Where some people get caught out is when you're plugged into shore power, it's happily passing through all of this power, and suddenly the shore power dies. And your inverter's like, don't worry, man, I got this. Oh, crap, I haven't got this. And it's way too much power for the inverter to handle. So that might have been one of their concerns there. There's nothing electrically stopping you. It's just that inverter would be limiting you. So there's a few options. You can choose to just invert one leg, but with a bigger inverter. So you can use, for example, a 5,000 watt inverter. There's also a couple of solutions if you wanted 2 inverters running to run both legs hot. And I know, and Dan, Gary, I'm going to look at you guys here. There's the automatic transfer switch. I know GoPower's got one that can do some fancy stuff. But the simple answer is you can invert any size of rig. It just gets more complex. The bigger the rig, the more complex the rig is. So we're going to call that the end of questions now. Thank you so much, everybody, for coming on to this. I hope it's been useful.
Thank you so much, Matt.